Hello everyone, we're here today with Dr. Paul Nachtigall, who needs no introduction into the marine mammal world, particularly in the acoustic world. So with no further ado, let's hear the talk between me and Dr. Nachtigall. Maybe we can talk a little bit like your initial studies, back in time, or about the difficulties as an acoustician. How was it before and how is it now, in terms of equipment, the use of equipment, how would you set up the like, for example, the audiograms, or
Oh,
the
yeah,
things
sure. I'd be happy to talk about that.
with the threshold, or
Yeah, when we started when I started doing hearing tests, it was all behavioral hearing tests. And so to do a behavioral hearing test, an audiogram, it requires that you train the animal. So the animal has to give you a response. So just like if you went to have your hearing test and you sat in the booth and the person said, when you hear a sound, raise your finger, you have to do the equivalent with an animal. You have to train the animal that when the animal hears something, it has to give you some sort of response.
right.
Well, being able to have an animal and train an animal to do that is a big process. So having an animal trained to do that takes, and to get an audiogram in that situation takes about 2 years.
Okay.
And so I got very interested in ways to make that happen faster. And after reading about and being very interested in temporary threshold shifts and things like that, knowing that there was really a need for those sorts of data, I thought we need a way to measure hearing faster. And people have been looking at auditory evoked potentials or looking at brainwave patterns, sound and wavelength patterns for a long time. But there hadn't been a really good solidification of a procedure. And I started working with Sasha Supin from the Russian Academy of Sciences, my colleague Sasha. And we started coming up with a very good way to quickly measure hearing using auditory evoked potentials. And that's simply the animal wears a little suction cup on its head and you pick up the brainwave patterns. And it's not unlike what most babies have now. So babies are tested when they're first born, whether or not they hear, by putting little suction cups on their heads, and then they look at the brainwave patterns in response to sound. And it's the same thing with the dolphins. You put little suction cups on the dolphin's head, and then you play sounds and you play pattern sounds. And if the brainwave patterns follow the sounds the patterns that you play, then you know that the animal hears. And then of course you vary the level of the sounds, and where the animal can just barely hear the sound, you have a threshold. Okay. And one of my students, Michelle Ewan Biter now, did some of the very early work comparing behavioral work with our whale Kina, False-killer whale Kina, comparing behavioral work and auditory evoked potential work, demonstrating that there was a very good correlation between the two techniques and the two procedures. Of course, that was followed up by a lot of work by the folks at the Navy Lab in San Diego, Finran and Hauser, with a lot of dolphins, showing a very similar finding that there was a good validity to the auditory evoked potential work. Now, being able to test the hearing of an animal, say within an hour as opposed to 2 years, makes a big difference. And that's allowed us to be able to measure the hearing of lots and lots of animals. Whereas in the past, we said, okay, we want to know what the hearing of this species is. We would get one animal and test it for 2 years and then say, okay, that's the hearing of that particular species. Well, there's some problems with doing that. There's some classic problems in doing that. When the killer whale was first tested back in 1960s, it was believed that the killer whales only heard up to 60 kilohertz, and that's because that one whale that was tested only heard up to 60 kilohertz. Of course, everybody said, oh, killer whales only hear up to 60 kilohertz, which was, of course, wrong. And Now we have the ability to measure more than one animal. Of course, we can measure lots of animals. You can measure 20 animals if you want to. And so it's a very good procedure for measuring hearing. However, there are new ones coming along, new techniques that are going to come along that are sort of encompass some parts of auditory evoked potential hearing, but also we still need to measure the hearing of other animals as well, some that we're not going to be able to get our hands on, put little suction cups on their heads. As you may remember, we tested the hearing, tried to test the hearing, we didn't test the hearing, we tried to test the hearing of a minke whale, and we had the grand idea to go out and catch a minke whale and test its hearing with this auditory evoked potential procedure. And we spent a lot of time and a lot of effort trying to catch a minke whale to test its hearing and never did. And up to this day, there's no good hearing test on any large whale. And so it's one of those things we really need. And so thinking about that and working with Vincent Yannick and others, it turns out that there's another procedure that might work. It turns out that even though a lot of dolphins and whales make very loud sounds when they echolocate, very sharp, loud sounds when they echolocate, they still can be very much startled by a loud sound. And you can measure that startle. And it turns out that the startle response is something you can measure, just like you can measure a behavioral sort of response. And with the startle response, you can change the startle, you can change the frequency of the sound that gives the animals a startle, and you can put a tag, sort of a tag on the animal. So the idea being that you could tag a bunch of wild animals and give them a sound that might startle them, and get an idea of how they hear by their startle. Now that's a procedure that hasn't come to fruition yet. It's an idea that Vincent is following up on, and we hope that that's gonna show up to be a good way to test hearing in the future. But that's for the future. We'll see what happens with that.
So, I mean, the species, as you said, that you study was only odontocetes and mainly the Delphinidae family, or did you do it on porpoises or other river dolphins, for example, or?
We haven't particularly. I haven't done it with river dolphins. The whole idea of auditory evoked potentials, though, would work, I'm sure, with river dolphins. I'm scanning through my brain at the moment of anybody that's done it with river dolphins. I don't know of any yet. All it takes is the ability to pick up. It's very broad. If we can do it on ourselves, we can do it on sea lions. You can do it on most mammals. I'm sure it would work on river dolphins. We've done it with a variety of different types of animals.
Right.
And the other thing that we did with Sasha was to look at what animals hear while they echolocate. That's another thing that.
Sorry, running out of battery here. Sorry to interrupt you. No, keep going.
I'm sorry, there's a bunch of interruptions that are going on with the people upstairs.
That's okay, that's okay.
I apologize for that.
Let me see if I can find the plug. Oh, it's here. Maybe cut this part when editing the video. Right, okay, perfect, sorry. So you were saying...
So another thing that came from the auditory evoked potential hearing is to be able to measure what an animal hears while it echolocates. Now, echolocation is a really fascinating phenomenon. It's just amazing that most of the odontocetes, every odontocete measures have been shown to be able to echolocate. And it's just an amazing thing to be able to do. It's a great way to find your food. And so most odontocetes have really excelled at doing that. And if you think about echolocation, everybody mostly has measured the clicks, because the clicks are fascinating, because animals make clicks to be able to echolocate. But the information is not in the click. The information for the animal doesn't come from the click. The information from the animal comes in hearing the echo produced from the click.
Okay.
So we've got very interested in what does the animal hear while it echolocates. And so Sasha and I worked on measuring what the animal heard while it echolocated. It turns out that you can do that with auditory evoked potentials by just measuring what it hears right after that echolocation click and presuming exactly knowing where the animal was going to receive the echo in time, and then measuring what the animal heard just at that point. Of course, you have to do it repetitively because they used multiple clicks. And so we looked at what the animal could hear while it echolocated and what it heard of its own echolocation returns. And we found some interesting things. One of which was they seemed to have volume control on their hearing. And while they echolocated, if in fact they were doing a relatively easy task, they didn't hear extremely well. But if there was a task where they were really looking for something, they really turned their hearing, now do I say down or up? They made their hearing much better. So in a situation where they really needed to hear and really wanted to stretch, they would hear much better. So we found that in echolocation experiments where they really needed to hear, they actually lowered their thresholds to hear much better.
Right.
We found that to be fascinating because there's the opposite of that too, because most everyone is very concerned, and rightfully so, about the effects of loud sound on animals. So everybody's been doing temporary threshold shift type experiments to say, well, if we play these really loud sound, what has the effect on animal hearing?
Mm-hmm.
Well, it turns out that if you have a volume control on your hearing, what happens? And so we explored what the volume control was like. And we looked at whether the animals could in fact control their hearing by teaching them that when we played one particular sound, shortly thereafter a loud sound would come. And we measured their hearing before we taught them that, and then measured their hearing right after that that warning sound was played.
Right.
And we found that they indeed learned to change their hearing in anticipating the loud sound, so that they essentially did this when we played the sound. And so they learned to control their hearing and plug their ears when a loud sound was about to come.
Right.
We know that they learned to do it by a number of experiments as well. And so we know that they have very good auditory control of their hearing mechanisms.
Mm-hmm. But we don't know exactly that there must be a limit for that threshold.
There
right?
are. We presume that there are limits. We've only showed that there, we only showed 15 to 20 dB change, which is a little bit more than what you might get if you used earplugs. So if you use those foam earplugs and put them in your ears, that usually gives you 12 to 15 dB change in your hearing. So they change theirs a little bit more than that. We don't know the mechanism yet. There are people trying to work on the mechanism now, but we're not sure what the mechanism that the animals, what the animals use to actually be able to do that. Mm-hmm. We think that it's a neural process, that the brain actually sends signals down to the sensory system, down to the sensory part of the ear, and actually tones down the receptors in the ear itself.
Mm-hmm.
We don't know.
Yeah, it's absolutely fascinating. All those things and that capabilities that animals have that we are still discovering. And of course, you're talking about echolocation, and you said that one of the challenge that you had during your career, and I know one of your big curiosities would be how does the big whales, the mysticets, do it? What's your opinion on the echolocation or not echolocation, as we know it at least, in mysticets? Do you think it's correct to say that they have or that they don't have echolocation? Now with these findings that of some fin whales and So
Yeah, you bring up a very fascinating question. In my younger years, I would have said, no, they don't have echolocation. But then I would say now, I'd say, do you have echolocation?
I
And
don't know. Do I?
it turns out that you do.
Oh, wow. Okay.
In fact, I teach this class. I teach this class every couple of years at CBAS. And what we do is I ask the students to set up an experiment where they have to test whether or not they have echolocation. And I started this because of working at a workshop in Denmark with Daniel Kish. Daniel Kish is a blind person who echolocates extremely well.
Okay.
And I always was of the opinion that people didn't echolocate until he showed me that I did. And if in fact if you had a book, I don't have one in front of me. You have a book and you put one and just close your eyes and you just keep talking and you put a book right in front of you, put a book right in front of yourself, you will notice a difference. And have somebody else hold the book, you will notice a difference in whether the book is there or not there when you speak.
Okay.
Now, technically, that is echolocation.
Right.
And it's very rudimentary echolocation, but it's echolocation. And in fact, if you set up an experiment like that and have the students, instead of talking, have them make clicks, go, and then have a book or a not book, set up an experiment. Most people very easily recognize whether or not there's something a couple of feet in front of them when they're making clicks.
Right.
So people echolocate. So if people echolocate, it's very likely that most animals that have very good ears, like we do, and that can make noise, have some form of echolocation. So I don't believe mysticetes have the type of echolocation that odontocetes do, where it's their primary sense for going after food. I don't think they do.
Mm-hmm.
I mean, it hasn't been demonstrated. That hasn't been demonstrated to be true. But to say they don't have echolocation would be to say that I don't have echolocation, and I know that I do.
Okay.
So it's not an all or none thing. It's a graded sort of thing. So Ron Schusterman, who was my mentor and was hired to prove that sea lions echolocated and didn't believe they did at all, and got a science paper demonstrating that they did not, had to take the all or none approach and say absolutely not, and was very, very adamant against the notion that sea lions echolocated. But in fact, I wouldn't believe my mentor anymore now that I have worked with Daniel Kish. Mm-hmm. I would say that, yeah, they don't echolocate like odontocetes do.
Yeah.
But I can't believe that they don't have some form of rudimentary echolocation.
Okay. Yeah, no, that's a very interesting topic, because obviously sometimes when we're trying to define what's an odontocete and what's a mysticete, the echolocation, it's one thing that people say, oh, odontocetes echolocate and mysticetes don't echolocate.
As a general rule, you could probably say that and get away with it.
Yeah.
But when it gets to the fine point of making, absolute definitions, you have to watch what you say.
Exactly. So should we say that maybe not, they don't have a system as odontocetes have, but they must have some sort of other process for echolocating? Well,
I don't know. We're not going to be. Somebody in the future is going to be able to study that in more detail. It's one of those open questions, and there are those that advocate for, and so it's one of those things that still remains open. It's one of those wonderful things that remains open.
Right.
And it's kind of nice. There are some things that are not absolutely fixed, and we don't have perfect answers.
Yes, but they don't they don't have so the mysticetes, they don't have the structure that odontocetes have, as in like the melon, so
they don't have all those structures, nor we presume.
Mm-hmm.
That's why we really we need we really need to, we presume that echolocation goes along with very high frequency hearing, but once again, if you look at nobody's had a sperm whale in a tank to really test echolocation in the old traditional way, but sperm whales most likely have a very, very good echolocation system. And yet sperm whales likely don't have very good high frequency hearing.
Okay.
They have relatively good low frequency hearing, and yet they have absolutely great echolocation system. So that's another thing that's really needed. We really need a very good audiogram on a sperm whale, and we don't have that yet either. So there's a lot of things that we really need information to get a very, sperm whales presumably, they make the loudest sounds in the animal kingdom. They make these huge, incredibly loud sounds, 240 dB, Ray 1 micropascal. That's a very, very loud sound. And they put it on a very pencil beam, and they find these squid, and they go off and dive deep and find them. And so they have this great echolocation system, but it's very different than the echolocation system of other odontocetes. But we still don't have an audiogram.
Right. So on the animals that you've done audiograms, what was the species that you've tested? What was the more challenged one, and why? So I mean, you've done in several animals like rhesus dog, obviously the false killer whale that it's the famous Kina.
Perhaps the most interesting one was the white-beaked dolphin off Iceland.
Okay.
And the white-beaked dolphin was my friend Lee Miller from the University of Southern Denmark had been recording very high frequency echolocation signals up to 300 kilohertz from white-beaked dolphins off of Denmark and Iceland. And he'd also read, there was a published paper by Mitzen, that the animals responded when 300 kilohertz pingers were placed in the water. And Lee believed that based on these data that these white-beaked dolphins heard very high frequencies up to 300 kilohertz. And so he's my friend, and we got together at a couple of meetings and we were talking about it. And he said, you have this new auditory evoked potential technique. Why don't you come to Denmark and we'll figure out, we'll measure the hearing of white-beaked dolphins. And I said, no, you don't have any white-beaked dolphins. Oh yeah, we have white-beaked dolphins. I said, yeah, but no, you don't have any that I can get my hands on and test. And he said, oh yeah, we'll get some. So he got money together from.
Oh, okay. We had a little issue with the sound, but.
Oh, I'm sorry.
Can you speak again?
Yes.
Okay, good. It's back. Okay. So you were saying you don't have.
What happens with Zoom? So he got some money together and invited me to Iceland, and he got a converted a fishing boat,
okay,
and got somebody that could go out and catch white-beaked dolphins. And so we went out and we caught white-beaked dolphins, which wasn't easy. It took us a long time.
Yeah, I imagine.
Not easy to catch dolphins. Caught white-beaked dolphins, brought them over to the side of the boat, put them in on a very nice little soundproof booth that was very lined with foam and very nice, filled with water on the boat, and then tested the hearing and then released the animal. And we found that in fact, white-beaked dolphins did hear very high frequencies, as high as the harbor porpoise, up to 180 kilohertz, which is very high, but not to 300 kilohertz.
Okay.
So that was most interesting. Some people got very angry at us because we had caught dolphins, but we caught dolphins, we tagged them, we released them, found that they were fine, and then then actually watched them tagged and what they did for a while. This was a big project. It was I don't know, maybe 10 of us that were involved in this whole thing.
Right.
And so it was really fascinating to be able to catch dolphins, measure their hearing, make sure they were okay, and release them.
Right.
And I had lots of wonderful students who had great opportunities, for that whole summer.
Because maybe the hearing tests that you do, it's mainly maybe with stranded animals or animals that are in captivity, or so it's difficult to get as you say, a live, healthy dolphin, right? So how is it? How does it work? Is it?
Yeah, nice. Well, let's see. For stranded animals, it's very good to test their hearing right away to see why they stranded. Are they healthy? It's a good part of a health physical exam to find out what caused them to strand.
Right.
And so if a stranded animal, if you can do a quick exam of their hearing, it helps to know, did they strand because they were overexposed to sound or not?
Mm-hmm.
And so if you have a good baseline on hearing in animals, whether the stranded was associated with hearing problems or being overexposed to sound. You can do that very fast if you need to. We've done a lot of work on beaches where animals strand. We go out and we set up a tank on the beach, and we put the animal in the tank, and we do everything we can to save the animal. And most of the effort is on saving the animal, but we also have the opportunity to measure its hearing to see what caused the stranding in the first place, whether there was some problem with its hearing.
Mm-hmm. Yeah, excellent. Yeah. And well, I mean, you got the chance to work in Portugal for at least 2 times with the stranded animals. And first one was the rhesus dolphin, right? That's stranded.
That was absolutely wonderful. That was just an amazing experience.
That's okay.
That wasn't the guys upstairs. That was me.
That's okay.
No, that was absolutely a wonderful opportunity. We were just learning how to do this. Working with Sasha, we were just learning how to do this. And Michelle Ewan-Biter and Aaron Mooney and myself had the opportunity to come to the Algarve, and we didn't even have our equipment on laptops. We had desktops, okay. And we had suitcases full of equipment. And then we heard that actually we got the call that the animals had stranded, and there was one that was listing, and they were worried about this particular animal, and it was an infant rhesus dolphin that still had the fetal folds on its side. And Eliu from
Eliu Vicente from the Marine. Eliu Vicente from the Marine.
Dos Santos.
Mm-hmm.
No.
Eliu Vicente. Eliu Vicente.
Yes, thank you. So anyway, Eliu invited us over, and we came over, and we spent a week at night. All the rest of the time, people were really working hard to save the animal, Eliu Vicente, mm-hmm. and working very hard to save the animal. And at night, we could work on testing the animal's hearing. And this was when we were just first getting to know what we were doing. And it was amazing. We were on telephone with Sasha in Russia. And what was amazing about it is that we were learning to do it at the same time we were gathering the most amazing data on that baby.
Right.
The baby had absolutely outstanding hearing. And what was amazing about that particular study was that I had done previous studies on rhesus dolphin hearing on behavioral audiograms. And it was like the killer whale audiogram. Everybody believed, based on our data, that rhesus dolphins didn't hear above 100 kilohertz. And whoa, that was the data. But that infant showed us that rhesus dolphins heard up to 150 kilohertz.
Wow.
So that rhesus dolphin infant redefined the audiogram for rhesus dolphins, and also showed that you could, in fact, get on an airplane in Hawaii, fly to Portugal, measure the hearing of a stranded animal, and then and whatever. And that was just an amazing experience to be able to come to Portugal and be able to do that.
Right.
The next one was to be able to go to Lisbon Zoo, for the long-fin pilot whale that's stranded Nazare. Nazare stranded at the beach, at the big surfing beach. And
that was actually the first time you and I worked together. It was very exciting.
Who linked the whole thing up, because we met at the meeting in England at Southampton.
Southampton, yeah, the acoustic meeting in Southampton, yeah. And
if it wasn't for you, I never would have realized that it was possible, and you set the whole thing up.
Oh no. You guys did all the work, so.
It would have happened without you. So that I would never have known. You set the whole thing. You and Ode, my students, set the whole thing up. It was incredible. So then we learned what the hearing of the long-fin pilot whale was from the stranded animal from Nazare, from the zoo in Lisbon.
Yeah.
And it's been just an amazing thing to be able to do. I've been so fortunate. And my students have had such great opportunities to be able to do those sorts of things.
For sure. And I got the chance to work with your students, and I mean the opportunities that you create to them are quite amazing and unique, I must say. And personally, I was very fortunate to be involved in the audiogram of the pilot whale, and was really a pleasure. And also, it's amazing, and I think people that don't work so much with acoustics sometimes might not have this perception, but the amount of equipment that you guys brought all the way from Hawaii to Portugal, it was insane.
It
was insane. It was just like, oh my God.
But that was just compared to what we brought the first time.
I imagine.
That was just a little bit.
It was crazy.
The first time we came to do the hearing of the infant rhesus dolphin, I think it was 7 suitcases, and the people that when we came to Portugal thought we were nuts, and they couldn't figure out what we were doing, and they kept all of our stuff overnight, and we would not leave it, and so we spent the first night at the customs when we landed, just trying to get our equipment out. It was a very interesting experience. So the second time we came, you think it was a lot of equipment, but it wasn't. That was the small amount.
I imagine. I imagine like 10 years before how it was, because at the time was so much. And it's been, I mean, this work that we did with the pilot whale, it's been more than 10 years now. So and the resource was way before. So I imagine the amount of equipment, it's just crazy. And another thing that I found very interesting while working with your team is that acousticians tend to be very, how should I say, very sort of scientific minded, like very objective in terms, and a lot of physics involved with acoustics. So there's like that sort of posture. And it's then very funny when you have an acoustician that needs a specific cable or a specific tool that needs to be that tool, otherwise nothing's gonna work. And you become like these most superstition people on earth. You need that tool, otherwise not gonna work. But like, could you replace for this one? No, it needs to be the other one. So.
It's true. It's true. We're not used to working in air,
right?
And we wanted to measure the hearing of polar bears, and so we were invited to go to Sweden, to Mats Amundin's place, and measure the hearing of the polar bears. Now, polar bears are a little more difficult than most odontocetes. One, there's all that fur, and you can't just clamp something on top.
Sure. Mm-hmm.
So, and you have to do it in air. We're used to working in air. And so, well, so first of all, the polar bear also is a very dangerous animal. So the polar bear has to be asleep during its annual physical. So it is anesthetized and put to sleep for its physical. And that's when you have to do the hearing while it's sleeping. The other thing is that we brought all this equipment, but we're not used to working in air. And so what we didn't have is a good sound level meter for measuring hearing in air or measure sound in air. So it's like, wow, how are we going to measure sound in air? And so what we had to do was find the sound level meter that we could measure. And it was a 2-hour drive to a hospital that would let us use their sound level
Wow.
meter. We drove for 2 hours to borrow a sound level meter.
Wow.
And at a hospital 2 hours.
And did you, what did the people at the hospital say?
I don't remember.
Like this crazy scientist.
Crazy.
No, I can imagine the reactions for sure. Especially because I've seen you and the team like asking for that, and that should have been like a very unique moment for sure.
Yeah, I do remember what very much so what Mats Amundin said the first time he took us down to be close to the bears, and they weren't asleep, of course. They hadn't been darted, and he said, "There's one thing I want you to remember." And he's looking at me and he's looking at me and he said, "This bear wants to kill you." Okay.
Most likely. No, yeah, but those are for sure amazing experience. And did you get, obviously, because you worked with a lot with animals that were under human care facilities, and also with the animals in the wild and in complicated situations such as stranded, which is always a very stressful moment for everybody. Did you have like a very frustrating moment that you would like to share, like something that you recall that was very, things didn't work at all? I'm sure you had a few, but any moment that you would like to share?
Yes, we going back to the polar bears.
Okay.
We measured the hearing of 3 polar bears, and like I said, we weren't very used to working in air, and of course we're used to working with bears. And
when was this, Paul? When was it? Yeah, but when? Like how long ago?
I don't know. It was published in 2005. So
okay, something like 20 years ago, more or less.
Yeah, roughly.
Okay.
And so anyway, so we did that work, and then we took along sound transmission devices to be able to transmit sound to the bear in air.
Mm-hmm.
But we didn't take high frequency sound transmitters along.
Right.
We only took them up to about where, okay, so we thought, okay, the polar bear makes only low frequency noises, doesn't make high frequency noises. Their prey are all low frequency. They shouldn't be. We didn't think that they would make high frequency noises. So our initial audiogram didn't go above 20 kilohertz.
Mm-hmm.
But we didn't get the typical U shape where you get an audiogram. So we didn't get to finish the audiogram. So a year later, we had the opportunity. Now they closed the facility down in Kolmarden Deer Park where we did the initial work. Mm-hmm. And they moved the bears to a bear refuge in Denmark. So it was just supposed to be a nice big bear refuge in Denmark. So we got invited to go to the bear refuge and finish the work. So myself and Sasha and I don't know, there were 3 or 4 of us. Mm-hmm. And we all went to the bear refuge in Denmark to finish the work. So we all got there and we did the whole thing, and we got the veterinarians, and the bears were having their physical, so they were asleep, and we did the whole work. And nothing worked.
The
Sasha
magic.
came from Russia, I came from Hawaii, the students came, everything, and we went the whole thing, and nothing
Nothing.
worked. Bears woke up and we never got the data. But till this day, we still don't know.
It's yeah.
Is that frustrating?
It's
Yes,
very frustrating. I imagine. Yes, because obviously, and I think sometimes people forget that there's a lot of logistics behind all these sort of also all of the experiments that we do, the field work that we do. There's a lot of preparation, and there's a lot of well, you know that obviously very, very well, because you've been traveling around the world trying to test hearing in different animals. And
the most frustrating part of that is that neither Sasha nor I know why it didn't work.
exactly. Exactly.
That's the worst part.
Yeah, no, I imagine it should be really frustrating. Although with acoustics, sometimes that it happens with everything, I think, in all the fields. But sometimes with the acoustics, it's so, I don't know, I just find it that there's a certain tendency for things sometimes not to work. Oh, now the hydrophone is not working. Now we lost one of the hydrophones, but the other one is working. Now there's a cable that broke. Now the tow array, got entangled.
It's sometimes very difficult. Sometimes you wonder, how in the world do we ever get any data?
No, but it's obviously fascinating, and especially because cetaceans are, I mean, most of all, they're acoustic animals, right? And
absolutely.
And therefore, obviously understanding the way it works, it's essential for us to know more about these animals. Yeah. And and so the acoustic studies started, when was it exactly? Like in the 50s, or
which
like
studies?
General studies in acoustics and marine mammals acoustics. The late 40s, 50s?
Oh, I don't, the mid 60s is when the first audiograms on echolocation wasn't presumed until the mid 60s. Mm-hmm. Then it just sort of went on from there. Right. So, but until the 1960s, nobody even knew what that animals echolocated.
Right.
I think it's 63. 63, 66 years like that. Mm-hmm. was the time that things
early
really started.
60s. Yeah. Okay. Yeah. And do you think we could, and correct me if I'm wrong, so echolocation was let's say confirmed or by Kent Norris, and was with the captivity dolphins, right?
Yes.
But then he did a lot of studies as well in the wild with the spinner dolphins and bottlenose dolphins and all that.
And all the spinner dolphins off of Hawaii. He had excellent books on the spinner dolphins off of Hawaii.
Exactly. Do you think we could have figured out echolocation if we didn't have that studies done in captivity first?
Well, we would know that it existed, but we wouldn't know how good it was.
Right.
It takes both types. That is, both types of laboratory work are essential if you're going to understand the system. It's sort of like science takes many approaches to develop an understanding. I just reviewed a paper. I shouldn't be saying this, but I just reviewed a paper. And for a long time we've been saying, oh, animals get old and they lose their high frequency hearing.
Right.
And they do lose their high frequency hearing. But now there's electron microscopy that goes on, where people can, after the animals die, they can take a look at their organs of cortea and their hearing systems and look at, well, exactly what does that mean?
Okay.
You know, what's going on on the inner ear? What are the morphological analogies to actually hearing loss at high frequencies? So you've got animals that are in captivity, and you can measure their audiograms, and then after they get old and die, then you can take a look at the inside of their ears, and you can look at the anatomy of the insides of their ears. And the thing is that it takes many views to get a total picture. And the thing is that there are many different sorts of questions to give you the total question, answers to many questions to give you the total picture. And to say that one gives you the real answer and one doesn't, it doesn't give you the whole thing. Mm-hmm. And I love field work. I love to be able to understand the ecology of the species, the ecology of how they fit in with the rest, the behavior. And I love to know the acoustics. I'd love to know how the acoustics fits in with that, and how they can hear one another, and why they do particular things because of how they've developed in their acoustics. And I like to know the anatomy. I like to know the anatomy of how all that works. And I like to know use the electron microscope to be able to look at the processes that go down at that level. Mm-hmm. But all of it together gives you a beautiful picture of what's going on. Right. So if you just take one and say, "Oh, this is science. This is real," and this is not, you don't get the whole picture of reality.
Right. Yeah, for sure. No, and it's great, and obviously you've worked with all sorts of situations, and that certainly gives you a very wide view of things, and a very wide perspective on how the system might work.
Things come in waves too. It's very interesting. I retired from my position as the director of our laboratory, and Lars Beider took over. Now, Lars Beider is primarily primarily does work with wild animals and works with wild animals. But that's the wave that's there. The wave for funding, the wave for advancement, the waves is that wave right now. Okay. So that's the one you should go with. So mm-hmm. Our laboratory shifted from being much more of an acoustic laboratory to where Lars's efforts are. Mm-hmm. So that's good. That's good because that's where things are right now. Mm-hmm. But that's things change. And I remember in the 60s and in the early 70s, things were more focused on in-laboratory acoustics, right, or in-laboratory sensory systems. So times change, but in the long run, that's why we keep a good bibliographic record. That's why we keep good journals around and write books, so that when we get a whole picture. Get the whole picture at one time is sort of develop the knowledge across time. Yeah, sure. And are you still supervising any students at the moment, or no? Okay, so you're done with students. I still sit on committees here and there, and I still work with students with committees, but I don't supervise any students. Right. But Ode, my student Ode has. I think she has 2 or 3 new students. Yeah. So I have grandchildren.
Well, now it's time to work on those questions that you've always had, and with the completely free time to just think about that and just enjoy a little bit more.
Working on air conditioners.
Some acoustics there as well. So what would be your recommendation, because obviously you had a lot of students over your career as a researcher and as a professor at university. What would be your advice for someone that is thinking about starting acoustics?
If you enjoy it, then do it.
But like, for example, what sort of knowledge should the student that really wants to go into the acoustic field should try to develop? Let's say, for example, acoustics has to do a lot with physics. So would be beneficial for a student to have a really good background in physics?
That's a wonderful background. I mean, physics is a great background. I had to learn all my physics on bootstrapping it.
Right.
I never took a course in it. I'm really an experimental psychologist, and so my formal training is in experimental psychology.
Right.
And psychophysics. Psychophysics I learned in experimental psychology, but physics itself is a wonderful thing to know. It's good for everything.
Sure.
And
sure.
Those of you that are strong in mathematics, go for it. It's absolutely wonderful. And those of you that are not so strong, don't be afraid. Don't be afraid, because I was never strong in mathematics, but I loved statistics. I didn't love statistics for the numbers. I loved it for the ideas.
Right.
You can love physics for the ideas too.
and you can also work with a team that has several sorts of experts and become a really strong team.
That's a very, very good point. That's a very good point. We lost Whitlow, Whitlow, my colleague, and he was a physicist, electrical engineer. And so you team up with people who have different strengths than you have, because nobody has them all. Nobody ever has all the strengths.
Yeah.
And then you learn so much from the other people you work with as well. If you don't get it in school, then you get it from your friends.
That's true. That's true.
You need it. And the more that you can do before you get into the field, the more you have in your arsenal.
I think we're having a little bit of. Say again?
I would love to have had much more of a physics background.
Physics background, yeah. Mm-hmm. Yeah, certainly an important tip for future acousticians that would, like to go that road. Yeah. Okay, and so in all the places that you've worked in the world, what was the one that you liked the most for whatever reason? Was in Portugal because we were super nice and friendly and all that.
There is no best. I just enjoyed doing. I enjoyed going. I enjoyed meeting people. I enjoyed all the new kinds of foods that I saw. I enjoyed all the wonderful people that I met. I enjoyed the work wherever I was. I enjoyed wherever I was. I loved spending time in Portugal. I passed it along. My daughter went and visited Lisbon, and she still talks about the little buns for breakfast with the custard. She still talks about that. She went to that. But I love wherever I've been. The people are wonderful. Particularly Portugal. Portugal is very good. But I also loved being in Denmark for a sabbatical. That was wonderful. I can't say that there's any place that I've been that I didn't like.
But certainly, some countries might have presents more logistical constraints. Maybe, I don't know if you worked in like.
The food is more difficult. The food is more difficult to get in Iceland.
Okay. Well, I think they're getting better now with that. but no, I mean in terms of like, for example, if you're going to work in a very remote area, of course, you need to think of all the extra things that you might need that you're not going to be able to go and drive a little bit to get it. And that, I don't know if you've experienced, well, you told us the polar bear story, which certainly was a constraint, but is there any other place that you had a little bit of
Well,
or equipment stuck in the at customers because they didn't know what it was and for what it was? I know that I had one time an hydrophone that was stuck in customs in Africa, in Gabon, for like 3 weeks until they realized that was nothing.
wasn't a bomb.
Yes, that I was not gonna, kill them all. So
Well, one of the things that we do before we go anywhere is to pack all of our equipment, make a long list of every piece of equipment, tell where we're going, why we're going there, and what the equipment does.
right. So that helps a little bit, for sure.
Mm-hmm.
For the people that are checking all the equipment.
And we put the letter on university letterhead.
Right.
And you sign it. So it looks very official.
Okay. And obviously all the permits that are necessary for all of these, because sometimes some students and people in general sometimes think, oh no, they're just scientists and they don't need the permits to do, or they can just get away with it, and it's certainly not the case.
No, you have to think like the person at the border.
Right, exactly. Yeah. Okay, and maybe a final question at a quite personal level, but who were the people that inspired you the most? Who were the people that you would look out to when you were a younger scientist, or that you still do? Maybe.
Most of them are gone.
Unfortunately.
Ron Schusterman was really my teacher.
Okay.
I never had him formally for a class. I never was in a university with him at the same time, but he used to come to our laboratory, and when I first started back in 1968, I talked to him, and he actually had his shop build me some equipment so that I could do vision. I could have the test vision of clawless otters, and he had the equipment built and delivered to the zoo, which was about 25 miles away.
Mm-hmm.
And it was amazing. I went to talk to him, and he helped me with the experimental design, and he built that piece of equipment for me and had it delivered to the zoo. And that was the start. And he never was my professor. There was never any formal relationship, but he was just always my mentor.
Okay.
And no matter where I went, I always had different professors. I always was in different universities, but he was always my teacher.
Right.
And he was just an amazing person.
Mm-hmm.
But there were so many. There's so many. Ken Norris is just an amazing person, and within, I worked at the Navy lab for many years, and
Mm-hmm.
and Bill Powell at the Navy lab was just an amazing. He was a genius, and my boss at the Navy lab was Hop Porter, and he's still a very good friend. He's still around. He's a great man. And Sam Ridgway remains a very, very good friend. And he's just an amazing man. And so there's just so many. I could just keep going and going.
Yeah.
There are, yeah, science is not a one person band. Science is a team. Science is a team. It's a very broad team. And, oh, Bertil Mole, and Lee Miller. You know, it's just going around, and Eliu too, by the way. Eliu.
And me. No.
Eliu too. I mean, it's just amazing. The more you do, the more people you meet, the more you realize how important the people are.
Right.
And it's just amazing. And your students, as you have students, your students become more and more important too. Yeah. Like all my students, I think through them. There was a wonderful thing that happened to me at the Barcelona meeting. My students organized a dinner, and it was just an absolute one of the highlights of my life. So all of my students, well, they weren't all there, but many of them were. Mm-hmm. And the dinner that my students put together, all of them were just, it was just an amazing highlight of my life.
I'm sure it was also a highlight for them, for sure. And yeah, and especially because I know some of your students, and the how much they admire you as not just as a person, but as a scientist as well.
So you know how lucky I am to have such good students.
you have such good, yeah, you are also lucky. Maybe that comes with experience. You're becoming more like this or that. You have a lot of choice as well. No, just like, no, for sure. A lot of the students, your students that I met, were incredible people, and some of them became really good friends with me, especially yours. It's a really good friend. Okay, Paul, is there any other recommendation, thoughts, any other message you want to leave for the youngers trying to survive in the marine mammal science?
Well, no.
There's still time for a career change. I don't know.
It's a wonderful life. How's that? It's a wonderful, wonderful life.
Yeah. Tough one though, right? We need to fight for it constantly. And I'm sure you've done that your entire life as well. Okay, Paul. So thank you so much. We talked about the people that inspired you, and certainly you are one of the people that inspires me. And I'm very lucky to have the chance to work with you, to know you more at a personal level as well as a friend. And it's been, you know, it's been really nice knowing you and learning everything from you. And yes, so you're one of my idols as well. Okay. I have a big list, but you're there, right there.
You could do much better.
You're in the top of the acousticians, I must say. I divide by topics. Acoustics, behavior, medicine, you know, like. No, but certainly you are, and it was you know, a great opportunity for me to it wasn't the first time I worked with acoustics. I had worked with acoustics before working with you. I worked with the sperm whale acoustics, but it was just, you know, just a little small thing. I wasn't really involved in the entire project, and it was obviously amazing to be involved in the audiogram of the pilot whale that we did, and get the chance to learn and be involved in everything that was happening, from, you know, from start, and that was from start till the end. So it was really great. And then of course, yeah, it's been a pleasure in the past decades to know you and to have you as a very good friend. So thank you so much for this, and yeah. And thank you for this talk as well, and I hope people will enjoy it and learn a few things. I've learned a few things, so I'm sure.
Hope so.
I'm sure they will. Okay, thank you so much, Paul.
You're welcome. Thank you.
Okay.
Bye-bye.